circles, chords, and tangents. A chord is a straight line joining any 2 points on the circumference of a circle. Let's look at the perpendicular bisector of a chord. Consider the figure below. The circle has radius O. PQ is a chord. The perpendicular bisector meets PQ at R and passes through O. Let's see whether the perpendicular line is really a bisector. Now consider the circle below. It has a radius R and center O. OA is equal to OB, which is equal to R, the radius of the circle. AON is a right-angled triangle such that AN squared is equal to R squared minus ON squared. That is according to Pythagoras' theorem, and call that equation 1. BON is also a right-angled triangle such that NB squared is equal to R squared minus ON squared. Equation 2. From equation 1 and 2, we can deduce that NB squared is equal to AN squared, and therefore NB is equal to AN. In general, a perpendicular bisector drawn from the center of a circle to a chord bisects the chord. 2. A perpendicular bisector of a chord passes through the center. Arc length. Remember that circumference is the perimeter of a circle. An arc is a part of the circumference of the circle. The larger arc is called major and the smaller is called the minor arc. Consider the circle below. The minor arc PQ subtends an angle theta at the center O. Length PQ is given by theta over 360 times 2 pi r. Look at equal chords. Consider the circle below. The chords AB and PQ are equal. Lines OC and OD are perpendicular to AB and PQ respectively. Experimentally, OC is equal to OD. Angle AOB is equal to angle POQ. In general, equal chords are equidistant from the center. Equal chords subtend equal angles at the center. For example, a chord of 16 cm is drawn on a circle of radius 12 cm, as shown below. Find the angle subtended by the minor arc at O. Find the length of this minor arc. In our solution, we have a sketch of that illustration. Sin theta is equal to 8 over 12, and theta is equal to 41.81 degrees. Angle AOB is twice theta, which is 83.62 degrees. Arc AB is given by theta over 360 times 2 pi r, and that is 83.62 over 360 times 2 pi r, and we shall have 17.52 centimeters. Internally intersecting chords. Consider the circle below. Chords AB and PQ intersect at M. The following is true about the figure. QM times PM is equal to AM times BM. For example, find the length Y in the figure below. Using the above convention, CE times DE will be equal to AE times BE, and 3 times Y is 7 times 2, and Y is 4.67 centimeters. Externally intersecting chords. Consider the figure below. Conventionally, BS times AS is equal to QS times PS. Notice the relationship is not similar to the internally intersecting chords. Example, find the distance x in the figure below. From the above, OQ times PQ is equal to MQ times NQ. That is, 5 plus x times x is equal to 11 times 3. Solving the quadratic equation, we have x is equal to minus 8.76 and x is 3.76 centimeters. We select the positive value of x since distance can never be a negative. Tangent and secant of a circle. Consider the figure below. A tangent is a line that touches a circle at only one point. AB is a tangent to the circle at x. A secant is a line that cuts the circle at 2 points. PQ is a secant to the circle. It is not the same as a chord. Construction of tangents. Method 1 involves constructing the tangent at any given point on the circle. From a circle, draw line OA through B. At B, construct a perpendicular line PQ, and PQ is a tangent to the circle at B. Method 2 involves drawing a tangent from a common point. From a circle with center O, draw line OA and mark A anywhere outside the circle. Construct a perpendicular to OA at M. With M as the center and MO as radius, mark two arcs on the circumference of the circle B and C. Join points AB and AC. AB and AC are equal and are tangents to the circle. In summary, at the point where a tangent touches the circle, the tangent is perpendicular to a line from the center. Two tangents drawn from a common point are equal. The tangents subtend equal angles at the center. This is illustrated below. AT is equal to BT. Theta 1 is equal to theta 2. Angle OAT and angle OBT are right-angled triangle, that is 90 degrees. Example, find the radius of the circle below. Angle ABO is 30 over 2, which is 15. Tan 15 degrees is R over 8 and R is 2.14 centimeters. Tangents common to two circles. Consider the figure below. PQ and RS are exterior or direct common tangents. Consider the other figure. AB and CD are exterior or transverse tangents. An example, two chords of radius 5 cm and 8 cm are such that their centers are 25 cm apart. Calculate the length of the tangent. The figure described is as below. In our solution, line AR is drawn to form a rectangle ARQP. ABR is a right-angled triangle. By Pythagoras theorem, AR squared is equal to AB squared minus BR squared, that is 25 squared minus 3 squared, and AR is 24.82 centimeters. AR is also equal to PQ, which is equal to 24.82 centimeters. Contact of circles. Consider the diagrams below. Q is the center of the larger circle P is the center of the smaller circle. The circles have only one common point. In summary, if two circles touch each other, the line joining their centers passes through the point of contact. If the circles touch externally, the distance between the centers is equal to the sum of the radii, i.e., PQ is equal to QS plus PS. If the circles touch internally, the distance between the centers is equal to the difference of the two radii, that is, PQ is QS minus PS. Angles in alternate segments. Consider the figure below. O is the center of the circle. RS is tangent to the circle at Q. Chord PQ divides the circle into two segments. Segment A is said to be alternate to angle PQS. Segment B is alternate to angle PQR. Segment A is alternate to segment B. Now consider the figure below. The angles marked X are equal and those marked Y are also equal. Chord QR makes angle X with a tangent at the point of contact. QR subtends an equal angle QPR on the alternate segment. Chord PR makes angle Y with the tangent at the point of contact. PR subtends an equal angle PQR on the alternate segment. In summary, a tangent and a chord form an angle at the point of contact that is equal to the angle subtended on the circumference of the circle on the alternate segment by that chord. That is illustrated by the figure below. We look at inscribed circles. A circle that touches the three sides of a triangle is an inscribed circle. To construct this, we bisect any two angles of the triangle and the point of intersection of the bisectors is the center of the circle. Circumscribed circle is a circle that touches all the vertices of a triangle, and to construct this, simply bisect any two sides of the triangle and the point of intersection of the bisectors is the center of the circle. An ascribed circle is a circle that touches the outside of one side of a triangle and the other two sides of that triangle when they are extended. To construct, extend any two sides of the triangle and bisect the angles formed between the extended sides and the third side. The point of intersection of the bisectors is the center of the ascribed circle. quick look at centroid of a triangle. A centroid is the point of intersection of lines joining the midpoints of a triangle to the vertices. To construct, simply join the midpoints of the sides of a triangle to the opposite vertices. This is illustrated below, and O is the centroid of triangle AOB. The centroid theorem indicates that the three medians of a triangle are concurrent. The points of intersection of the midpoints is a third of the way along each median, that is, LO is equal to a third LA, OM is a third BM, and NO is a third NC. The point of intersection of the medians is the centroid of a triangle. Finally, we look at the orthocenter of a triangle, and the orthocenter theorem indicates that the altitudes of a triangle are concurrent. Their points of intersection is the orthocenter of the triangle. From the figure PQR, O is the orthocenter of the triangle.
Choose a path, choose a direction, choose your day, choose your hours, choose to network, choose a strategy, choose to create, choose your media, choose to care, choose to inspire, choose to listen, choose to learn, choose to train, choose to compete. Newcastle College, why choose anywhere else?